Hi everyone, we're continuing on from the previous episode where we set up this Metasound as part of our car crash audio system. The first thing we need to do is to add the Metasound to the player control blueprint. So have it highlighted here, and then once it's highlighted you can go to the add button, and if you look on audio you can see that that Metasound is present there. If you click on that, it will add it to this list of components. If I go and search it now, it should come up with ms underscore sound effects, collision, and you can see there it is right there. So that's what's going to allow us to communicate with that Metasound inside of the player control blueprints. With the Metasound component highlighted here, what I want you to do is go over to the details panel and make sure that your attenuation and attenuation spatialization settings are the same as mine. So on allow spatialization and override attenuation, they're both checked. On enable spatialization, that's checked, and the spatialization method is panning. This setting in particular is going to make it so that later on with a bit of work we're going to do inside of the event graph, if we crash on the left we'll hear it on the left, if we crash on the right we'll hear it on the right, if we crash anywhere between that all the way to the centre we'll start to hear it at the centre of the stereo image. So that's what's going to allow the crash sound to pan around that stereo image basically. The next thing we're going to do is go ahead and highlight the mesh of our player control blueprint. So in my case this is the body of the car. What I want you to do is then go down to the events section, and on component hits I want you to click the little plus icon. What this is going to do is it's going to create an event where every time the mesh of the vehicle hits something else which has collision, it's going to fire off an event which we can use to basically play the collision sound that we created inside of the Metasound. You can see I've already added one, so if I click on this it'll take me to the one that I've added, and then from here we're feeding that into a call function which I'll go over now. Okay, so to have a call function obviously you need a custom event. So if I just zoom out and go over to my collision area, this is the custom event that we're referring to. So I've added this custom event. You right click here and then type in custom events. So you can add your own custom events. And then from here, I've got a bunch of information that this custom event is going to be carrying across from the call function we were just talking about. So I've clicked the little add button here and I've added the primitive components for the hit components, the actor for the other actor, the primitive components for the other comp, the vector for the normal impulse, and a hit result for the hit. So the way I found out what I needed to add there is simply by going over to this and by essentially dangling the cursor over here, and it will actually tell you what each of these are. So it says hit components, which is a primitive component object reference. This one is an actor object reference. This one is a primitive component object reference. This one's obviously a vector. And this one is a hit result structure by ref. So this is how I knew what to add to our custom event so that our call function could carry across all of that data which we're going to be needing. We're going to be using that later on. So hopefully that makes sense. So you need to go and add all of those things into your custom events so that it carries that data across nicely to this section that we're about to create. Now, one issue you might be running into is the fact that this on-component hit mesh might not be firing off hit events when you crash. One way of checking this is simply by doing a print string. So if I do a print string and I'll type into here crash. Now, what will happen is if this fires off and the words say crash, it means it's working for you, and that's good. If you find it doesn't say crash every time you crash your vehicle, then it's not working for you. So check mine now just to demonstrate it working correctly. Okay, there we go. Sorry, it was just lagging out a little bit there. So if I go and crash, you can see there it says crash. Now, if it's not working for you, it's very simple to fix. I'll get rid of that. You keep yours for now if it's not working for you, just so that you can troubleshoot it. The problem that you're having is likely related to the fact that the mesh does not have a, in fact it'll be easy if I just type in simulation here. So the problem you're having is the fact that your mesh is not firing off hit events. There we go, simulation generates hit events. You want that to be checked. Another thing that you're going to have to do, if I get rid of this, is on the skeletal mesh assets that you're using, if you go ahead and click that, and then from here you can open up the physics assets, and at the moment you can see I'm using a sort of cube type of shape here. If I go ahead and select that, you might have a shape which sort of wraps around the body of the vehicle. Whatever you've got, go ahead and highlight the main physics shape you're using for your asset essentially. And if you look around here, you can see on the collision, simulation generates hit events is checked here also. So go ahead and make sure both of those are checked. And now when you go back into the event graph, you should be receiving hit events into your call function here. So go ahead and check that, make sure it's working for you, and then we'll get into the next section. Now with all this set up, let's go ahead and go over to the collision audio system that we've got inside of the event graph. So as you know, coming off this custom event, we're going to be going into a set world location. The target of this world location is going to be our Metasound. Essentially what we want to do is, I'll actually go into the little viewport here. So this is where I've got our little crash speaker here. That's the Metasound, the crash Metasound. If I go ahead and go down, you see highlighted Metasound sound effects, collision metal. That is the little speaker that represents the sound that is being outputted out of the Metasound we created in the previous episode. So what we want to do is we want to make it so that this speaker is being moved around the vehicle depending on where we crash. So let's say we crash on this bumper here. We want this speaker to teleport over here so that we hear that crash happen from that location. So that's essentially why we're using the set world location of this Metasound as the target. So this is where we're taking the normal impulse data here. So we're going new location into a multiply node. The multiply node is taking the normal impulse at the top, and at the bottom we're taking the 3 data points from the vector, and we're essentially inverting them by multiplying them by -1. So we invert them, and then that is going to set the world location. And that gets it to move the speaker into the correct space on the vehicle, basically. Now, the next thing we're doing is we've created a variable called VMC forward speed, and we're setting that float value. What we're essentially doing is we're simplifying this so that we don't have to write this value coming out of here every single time we need it. It's just going to make things a bit easier. Now you may have seen this before. If you've been following along, go ahead and copy this across from another section in the event graph and just bring it over here. But if you are just joining us, what we're doing is we're getting the vehicle movement components. From there we're getting the forward speed. We're multiplying that by a float with the variable is miles per hour, pick A. So essentially it's converting this value here into either miles per hour or kilometers per hour. And then we're going into the absolute node, which is going to make it so that, for instance, if we're reversing, we would usually get negative values. We want that to always be positive. So if we are reversing, it's going to take the negative values coming out of here and make it so that those are always positive values. And then we're setting our VMC forward speed as the variable. Okay, from there, we're going into a branch, and the condition of that branch is, are we greater than 3 miles per hour or kilometers per hour based on that variable? So we've just set the value here of whatever the forward speed is. And now we're getting that value to essentially query, are we moving faster than 3 miles per hour or kilometers per hour? I'll just use kilometers per hour from here on. If we're not moving faster than 3, we're moving very slow, in which case I want to set the collision metal sound effects for our Metasound. I want to execute a trigger to tell it to stop. So call met_stop. which is a trigger input we have created inside of the Metasound. So you can see here, col met stop is here. That's going to go into the trigger delay and cause all of these wave players to stop essentially. So we're telling it to stop. If it's true, we then want to reset that stop, because as you can see here, we're using trigger delays, and if we are using trigger delays, we can run into issues if we do not hit the reset when we do need the sound. It can prematurely stop the sound. So that's why we are essentially firing off the colmet underscore stop underscore resets to fire off into the trigger delays to make sure it clears any triggers it might be holding. Next thing we're doing is we're coming into this. I'll literally just read it from here. It basically says, have we crashed recently? If we have, do nothing. If we haven't, execute true. So what it is, it's basically a branch. We're going into a condition and we're saying, are we less than 0 as an integer? What we're doing is we're basically counting how many times we've crashed in a given moment, and this will make sense later down the event graph. So what will happen if we don't do this? If let's say we're skimming off the wall, it will play the crash sound every single frame, and it'll be very loud, very horrible, and not at all what we want. So what we're going to be doing is we're going to be using a variable called collision. This is an array variable. We're using the find function here, and we're taking in the other actor. You can see this line is running across here, and it's coming up into the find. So we're getting that collision on the array, we're finding it, and if we find we're more than 0, then we're going to do nothing. We're not going to play anything, because we don't want that sort of cacophony of crashes happening every time we're touching a wall. We just want to hear one crash if we make a collision, and then leave it for a little while. And then if we're still sort of colliding with something, we'll play another crash. So that's essentially the idea of this. And it'll make more sense as we get further along. Now coming out of this branch, we've just crashed. We're less than 0. We're going to say Metasound sound effects collision metal. There's our reference, and we're going to be telling it to play. So that's the equivalent of going in here and clicking the play button, essentially. From here, we're adding the collided actor to the array. So this is where we're going to come back here, and let's say once we've crashed, because it's been added to here on our collision array variable, it's now, if it tries to crash again, it's going to hit this. This is going to be, it's going to be more than 0, and it won't crash again. So that's essentially what's happening between this section and this section. And then we have this section, which we'll get to in a minute, so it'll make a bit more sense in a moment. So now continuing on, this is the section where we're setting volume of crash sound based on the VMC forward speed and also which camera to use. So in my vehicle, I use different cameras. You can use the bonnet cam and you can use the chase cam. So depending on what camera we're using, we're going to select a different set of ranges, so that if you're using the bonnet cam, it's going to be a bit louder because you're closer to the vehicle. And if you're using the chase cam, it's going to be a bit quieter because you're actually further away from the vehicle. So I wanted that to translate depending on which camera you're using. So what we're doing is we're using the set float parameter. In name, that's called master gain. Our reference is obviously the Metasound collision that we've created here, the Metasound sound effects collision metal. So we've got a reference to that. Now on the in float, we're saying select float. Then I've got a variable here called is back camera, which is a boolean. I think I've been through this on other episodes, so I'm setting that over here. So I'll let you have a little look at this. This isn't too important since basically this is just going to be telling us which camera is on by setting these to true and false essentially. So I'll go back across. Where are we? Collision, here we go. So essentially this is going to pick A or B depending on is back camera true or false. So from here, we're coming out, and I'm just going to read it from this side now. So we're getting a reference to the VMC forward speed that we created. We're going into 2 map range clamped. And then from there, we're saying in range A, 0, in range B, 160. And then the out ranges are 0.25 or 1.2. So if we're going 160 kilometers per hour, then we're going to be setting the master gain to 1.2 in the event that the back camera is true, if that makes sense. So master gain is getting set to 1.2 at 160 kilometers per hour if the back camera is true. It was a bit of a mouthful. Now, if the back camera isn't true, we're going to be taking the values from this map range clamped. So if from 0 to 160 kilometers per hour, the crash is going to be from 0.25 to 1.7 on the master gain. So if I go over here, just to give it a bit more context, the master gain is over here. So essentially we're controlling this fader. The faster we move, the more this fader is going to go up. The slower we're moving when we crash, the more this fader is going to be quiet. So I can just leave that whatever it is because we're setting that elsewhere essentially. So that is essentially what's happening here. Hopefully that made sense. It was a bit of a mouthful to explain. Now here we're getting a call function for the custom events, clear collision. So it's a call function for this custom event that we created over here. So this relates to this section, and this section. The problem we have without this is that once we crash, it's adding it to the array, and then we can never be true again. But by using this clear collision custom event that we've created, we're going into a delay of 1 second. And then from there, we're then firing off into collision and we're clearing this variable array of any data so that it can be set back to 0, which means this can be true again. So that's what's happening. We created this custom event into a delay. We've got this set up here. And then we're using this call function to carry that data across here, just because I thought it would be a bit neater and tidier to have this close to this section because they all relate to each other. Basically, visually it's nicer to look at. Right, now from here we're actually right near the end now. So we've cleared the collision so that we can use the crash again after 1 second has passed. Then we're using a multi-gate to cycle through all the different crash sounds that we have. So in our Metasound, we're essentially mixing together all these different crash sounds with these different wave players. And you can see we actually are triggering them from here. So play CM1, play CM2, play CM3. And it's from here where we're going to be selecting which of these triggers we're going to fire off to cause these wave players to fire off. So on the multi-gate, we've got set to loop. The start index is -1. Random is false. And every time it receives an execution pulse, it's going to be going up to play CM1, then play CM2, then play CM3. Every single execution pulse, it's going to cycle through these essentially. And that's going to allow us so that we have variation every time we crash. We're not just getting the same boring sound every time we crash. So I think that's everything. Let's go and test it out. It should be working for you now if you have all that down and you've followed along. Let's go take a quick listen. Okay, let's start off by crashing less than 3 miles per hour. So I'll go kilometers per hour. So I'll go less than 3 and I'll just very slightly, gently touch the wall. So there we go. We're now touching the wall, we're colliding with the wall, and we're not hearing a crash. If I reverse now, and I go more than 3 miles per hour, let's say I'll just do 10, very, very slow, we now hear the crash. The other thing you want to check is that it works when you reverse. If you have your values so that there are negative values, none of this is going to be working. If you did use the absolute node, which is going to convert it so that when you're reversing, it's going to be giving a positive value for the forward speed. This should work fine. So I'll go plus 3 miles per hour. And we crash. Now you want to check, is it panning correctly? If I go to my front camera, I'll go to the right ear. Crashes over to the right. If I go to the left, over to the left. If I hit these, you can hear it all around the car, which is what we want. Next thing we will check is it working with more speed? We've heard it when it's quiet, when we're driving quite slow. Let's get a bit more speed up and crash a bit harder. In fact, I'll go to the tunnel because I can get a bit more speed up coming out of the tunnel. And I can usually hilariously throw myself off the map. So we're getting our speed up, we're going to crash into this barrier. And we didn't quite make it off the map, but you can hear there, it's getting louder. The faster we are moving, the faster we're moving when we crash, it's louder. The slower we're moving, it's a quieter sound. So it's all working fine. Hopefully you got that working right. Let me know if you have any problems in the comments. But anyway, thank you very much for watching. I'll catch you next time.